Alright, so really what we're trying to do is take this equation and rewrite it in a different form. Okay? And the way we can do that is take the numerator divided by the denominator. So we set up our long division like this. X plus 3 would go out here. Underneath here we'd have x squared plus x minus 5. You start by doing x squared divided by x. Or you could just think, what times x would give me x squared? Either way, an answer is going to be x. Then you take x times x, that's x squared. You keep your exponents the same exponents lined up. X times positive 3 would be positive 3x. Then you're supposed to subtract. So you could just subtract and go x squared minus x squared would be 0x squared. 1x minus 3x would be negative 2x. That's fine. I would though suggest that instead of subtracting, you add the opposite. It just seems that over the years of teaching this that people make more mistakes when I have them do that, or make less mistakes, excuse me. So x plus negative 3x is negative 2x. Then you bring down the minus 5. Then you think negative 2x divided by x would be what? Negative 2. Or you can think, what times x would give me negative 2x? Either way, it's going to have a minus 2 here. So take negative 2 times x, it's negative 2x. Negative 2 times positive 3, negative 6. Any questions so far? Now we're going to subtract, but instead of subtracting, you can add the opposite. So you get a remainder of negative 5 plus 6 would be 1. So if you're going to rewrite this equation, this is what it would look like. You get an answer of x minus 2 plus a remainder of 1 over x plus 3. These functions are exactly the same. If you graph this function and you graph this function, the graphs are going to look exactly the same. It's just a different way of writing the exact same equation. Now, from there, you should know what to do to figure out what the slant asymptote is. And you're always going to start the slant asymptote equation with y, so make sure you don't forget y equals. And all you do is you ignore the part that has the x on the bottom. Because when x gets really big, this fractional part of the problem will get close to 0. So when x is big, this fraction has very little effect on the graph. So the graph, when x is big, this curved graph will get very close to this straight line, y equal x minus 2. And that's the slant asymptote. All right, now I'll give you a few more minutes to finish the problem.